Hey everyone, and welcome. There's this force that's in charge of literally every move you make, but we almost never even think about it. It's the reason you can walk, the reason your car stops, and the reason your stuff wears out. So today, let's dive into the unseen world of friction. So, here's the big question we're going to tackle. What's the deal with friction? Is it our best friend, the thing that makes our world possible, or is it this constant enemy we're always fighting against? As you're about to see, the truth is, it's a little bit of both. To really get to the bottom of that, we've got to zoom way, way in. We need to understand what is actually happening on a microscopic level when any two things rub together. So let's get into the science of grip. At its heart, friction is simply the force that fights back against motion. I mean, think about it. If you push a box to the right, friction pushes back to the left. It's like the universe's natural built-in braking system. It always resists things sliding around. So where does this invisible force even come from? Well, picture this. Even a surface that feels perfectly smooth, like a pane of glass, isn't smooth at all. If you could look at it under a powerful enough microscope, you'd see this rugged landscape of tiny mountains and valleys. And when two of these surfaces touch, all those little irregularities snag and lock into each other. That resistance, that's friction. So just to quickly recap its main characteristics, friction always pushes against the direction of motion. How strong it is depends on how rough the surfaces are and how heavy the object is. And, as you definitely know from rubbing your hands together on a cold day, it generates heat. Okay, with that science in mind, let's start by making the case for friction as the unsung hero of our daily lives. Because seriously, without it, our world would just fall apart. Just think about it for a second. The only reason you can write with a pen is the friction between the tip and the paper. The only reason you can stand up and walk across the room without just slipping and falling? Yep, friction. And most critically, the grip your car tires have on the road and the brakes that stop that car from crashing, it's all friction. But, of course, it's not all good news. For every helpful grip, there's a destructive grind. So now, let's flip the script and look at friction's role as the enemy. Friction is exactly why the soles of your shoes wear out. It's why parts in an engine grind each other down and eventually fail. And all that heat it creates, well, most of the time, that's just wasted energy. It's this constant, relentless force of decay and inefficiency. Okay, so we've got this two-faced force, right? Sometimes we desperately need more of it, and sometimes we need way less. And this has led to some pretty clever engineering. Let's dig into how we've learned to tame and control it. So first off, what do we do when we actually need more grip? How do we amplify friction when we need it for safety and for control? It really boils down to two main strategies. First, you just press the surfaces together harder. Think about squeezing your bike's brake levers. You're physically forcing those pads onto the wheel. The second method is to make the surfaces rougher. This is exactly why tires have treads and why shoes have those textured soles. It's all about maximizing that grip. But what about the opposite problem? What are our main strategies for fighting back against friction when it's just causing wear and tear and wasting our energy? For this, we have three primary weapons. We can polish surfaces to make them incredibly smooth, basically flattening out those microscopic mountains. We can add lubricants like oil or grease, which create a super thin, slippery film so the surfaces barely even touch. And, maybe the most ingenious of all, we use wheels and ball bearings to switch from a high-friction slide to a super low-friction roll. And that last point about rolling is, well, it's a huge deal. Just look at this. Static friction. That's the force you have to overcome just to get something to move in the first place, is by far the strongest. That's because those microscopic mountains have had time to settle in and lock together. But now look at rolling friction. Wow, it is so much weaker. It's a total game changer, and that massive difference is the secret behind one of humanity's greatest inventions, the wheel. Now, friction doesn't just happen between solid objects. Anytime something moves through a liquid or a gas, like the air or the water, it experiences a type of fluid friction we simply call drag. And just like with solid friction, we've figured out ways to reduce drag, too. A big, boxy shape creates a ton of it, which wastes a lot of energy, and that's why we often look to nature for inspiration. The streamlined shapes of birds and fish are perfectly evolved to cut through air and water with minimal resistance, and that's what inspires the sleek designs of our airplanes, boats, and high-speed trains. So, after all this, what's the final verdict?
Is friction a friend or a foe? Well, it really comes down to this simple idea. Friction is a necessary evil. We absolutely can't live without it, but at the same time, we can't live with it without constantly fighting to manage it.
And that brings us to one final mind-bending thought to leave you with. What would a truly frictionless world actually look like? Just imagine it. You couldn't walk, you couldn't hold anything, and once something started moving, it could never stop. It's a quiet, unseen force for sure, but it's the force that holds our entire world together.